Hi there, welcome back. I've taken out the second channel of the Marantz 250M and I have no idea what this channel is like compared to the other one, but I do notice that at least we have some consistency in the cock-ups. There's a resistor there that's tied to the negative supply with a funny piece of wire, which isn't even soldered to the resistor. So at least we're consistently cocked up here, and which means I have to go through this whole thing again. I was going to anyway, but it does restore my faith in the choice that I made. I have to go through the whole thing again and check everything. Let's have a closer look. No great mysteries so far. That pot there is a bit rusty, but it's probably okay. It looks like all the mods that were made in the first one have been made here as well. In other words, practically all transistors have been swapped out. Capacitors, a lot of the resistors. Somebody was trying to turn this into a better amp. And I've read quite a bit about this amp on the web, and the one thing that I keep coming across is how unstable this bugger can be. Apparently it's quite a killer, and that's why I'm being extra careful with everything. So let me get this guy out and see what the underside looks like. Again, testament to consistency. Exactly the same mods were attempted on there. The tracks were cut, so I'll have to remake those. We've got the same thing down here, down there. Somebody tried changing something dramatically and then changed their minds and went back to the original. Nothing much else that's different. We've got a blown or burnt connector there as well. That's probably why that negative supply was being shorted to one of those resistors, because that track's not making contact anymore, or that rivet. The positive one is fine. So yeah, I know what I need to do. Oh, this one has actually got 4 transistors in here, so the 2 pairs are in there. I'm not sure if they're okay or not, I'll check. But I better get started. It's not going to do itself. Okay, we're back. I found quite a few little anomalies on this thing. I've gone through what I've changed on the other one, and this one is basically the same. Those 2 power resistors. Every component was pulled out and checked. Every contact, every joint was pulled out or checked, because, as you may recall, I had to rebuild some of the tracks. And this is the final result. A lot of dry solder joints were repaired here, and some of the tracks were repaired. I still need to paint those green, solder mask color. That connector there was the one I had to rebuild, like I did the first channel, because that one was burnt out. The other 2 over there were fine. This one was a little bit more tricky because there was quite a bit more damage here than on the first channel. So there was quite a bit of patching that needed to be done there, and it's as good as it can get, but I wish it was easier to do those repairs, or actually I wish they'd never been made necessary in the first place. But anyway, that thing's done, and I hope that when I switch this on, it works. We'll see. But let me show you on the schematic what happened, what I had to do. Over here we have the other channel, the first channel that I repaired. So I moved on to the second one, and here it is. And what we see here is actually just not that much, because most of the problems here were actually bad connectors and tracks, and a couple of components that were off. Let me zoom in and show you. Over here, this capacitor was reverse biased, or put in the wrong way on the board. And then I found that this is actually a mistake of theirs, because this is how the schematic is shown. Positive to the left, the negative to the right. It doesn't really matter, because this thing here is 0 volts. That one there is supposed to be about 0.6 volts. Now that means that there's very low voltage, DC voltage across this. So it shouldn't really make that much difference, but they do choose to put positive on this side. And when you look at the actual board layout, this capacitor here, this is the capacitor here. I've obviously inverted the board so I can see it as I look down on the components, has the positive going up. In other words, contrary to what we have on here. So I'm not so sure that the one I found fitted the wrong way in the first one was wrong or not. But what I did do is I replaced this one as well, just for good measure. What else did we have? A lot of bad solder joints here, because these things were all removed. All the transistors were removed. The capacitors were swapped out. I think just about every component, with the exception of a few of the very small resistors and the offset trimmers, were replaced. And not well done either. Every transistor had to be checked, because it was fitted with the pins hanging up at the top, or rather way off the board. So I had to test them and fit them nicely onto the board. That resistor there is another one that was, it shows 220 and there was 330 in the board, same as the previous one. That capacitor, that big 220 microfarad, that was also replaced because the ESR was a bit too high. What else do we have here? That resistor was completely open. Now that concerns me, because why would it be open? I mean, this is a 1 watt resistor, 39 ohms. And that shouldn't have happened, but it did. So, I mean, it could have been, you know, bad solder joints, a short, something else that blew that. So I'm anxious to see what happens when I switch this on, because I didn't have a 39 ohm 1 watt. So what I did was I used a 47 ohm 2 watts with a 220 ohm in parallel. It comes out at 38.7 or 38.8. This is just to get me to test it before I'm going to order stuff, and it takes a while to arrive. I don't want to sit and wait for one resistor, so we can obviously test it. These transistors are both in there, those two in parallel and those two in parallel. That resistor is 5.6 ohm, and it's reading about 7 or 8. So I'm going to have to replace that, and probably that one as well. But I left it in for now for testing. And then, of course, we have the problem with the positive supply that needed to be completely rebuilt. And that's it. It doesn't. This is the irony of this whole thing. It doesn't look like too much, but it's a hell of a lot of work, because you literally can't trust any connection, any contact, anything on this board. But contrary to what some of my viewers have been commenting about what a nightmare this is, I keep reminding myself and keep repeating to those who ask that this is my hobby. This is what I love to do. And if this thing didn't have faults, it would be boring. So, yeah, I'm not complaining. The more challenging it is, I suppose, the better you feel when you finally get it working. Sometimes I forget that too. But hey, that's what happens. Anyway, time, I think, for testing. I'm always a little bit anxious when it comes to doing the testing, because you do a hell of a lot of work here, and it could all be going back to the drawing board if it doesn't work, or if you start seeing smoke or something like that. Actually, if you see smoke, it's not so bad, because you can sometimes see where it's smoking. It's when it stops working, you don't see anything. That's a real bummer. Anyway, enough blab. Let me carry on here. Right, so we're ready for the tests. Now, what do we have here? We have the board module. I have fitted it in. I've been very, very careful to ensure that the pins fit nicely into the transistors. Ideally, you put in the board and the transistors fit in one at a time afterwards. Otherwise, you might get a pin that slips out. It happened when I first tried to put it in, so be very, very careful. But we have it working now. We have it fitted properly now. I have an audio signal coming in here, which isn't connected yet. I have the meters as follows. This one, Big Brother, is measuring the voltage across the 2.1 ohm resistors. Now that should give us, ultimately we'll set that for about 12 millivolts, which is about 60 milliamps bias current, idle current. Now at the moment what I've done is I've set the bias pot totally counterclockwise, which is what they instruct you to do. I have no idea where the DC offset's going to be, and that's being measured by that meter, Little Brother. Now Little Brother is connected to ground and to the output connector. I have a 8 ohm power resistor across the output as the load. I have the power supply, the positive, the negative, and the ground from the amp connected to here. I have the dummy load with one light on, 40 watt bulb. That's the only one that's on, the others are off. In other words, we've got a 40 watt bulb in series with this. That makes it the maximum current limit possible. The limit selection is on, so it's not bypassed. It's off at the moment, and it's on the safe mode, which is no mains earth connected, and it's going through the isolation transformer. I think everything has been taken care of, and I'm not going to test with the signal just yet. I want to see if I can get a stable situation here with the output offset and also the bias current. So let's see what we can do. Give it a bit of backlight. Well, enough dallying around, I'm going to hit it. So that should come on bright and maybe dim a bit, which it has a bit. Because the protection circuit is still connected to the amp, it comes off, I believe, a separate secondary winding on there, and it's not seeing any DC because the outputs are all flying loose. The protection relay is actually kicked in. In other words, it's not seeing any fault condition, but we'll get to that later. What I see now is 140 milliamps coming through the dim bulb tester. The amp is seeing 176 volts AC due to the current draw through the lamp. But what we have here is 162 millivolts DC offset at the output. And it has no signal, but it does have the dummy load in. So let me try and zero this. Gone the other way. These pots, well, 3 milliamps, 4 millivolts, sorry, millivolts, 7, 8, going up a bit. It's probably as good as it's going to get for now. Well, that's pretty good, isn't it? 5 millivolts. Okay, I'm leaving that there for now. They say you can go up to 50. I've got 1.17 milliamps flowing through the as a bias quiescent current. I'm going to give it a bit more juice here. Put in another bulb. We now have a 100 watt bulb in series. The current's gone up to just under 200 milliamps and the voltage has gone up to 199 AC. Now remember, this is a 230 volts system supply. That thing is still stable. I'm going to give it one more. Now I've got 140 watt bulbs in series there. 230 milliamps, 213 volts. That's as far as I'm going to go in terms of removing the protection, because what I want to do now is just increase this slightly. Now, it says you should go to 15 millivolts or up to 15 millivolts, 12 to 15. I'm going to go up to about 6 because I've got a feeling this thing will drift somewhat. Let's see how accurate that can be. There we go. Woo. Okay. Now the reason this is 6 is because it actually, this particular one has the 4 output transistors in parallel. 2 in parallel, 2 in parallel, 2 in parallel. Whereas the first module we tested only had 1 each. Now obviously it's adjusting, it's going up, and it will go up for a while. You have to let this settle. There's very little current going through here. Now what should happen is that it should stabilize, and if it starts getting too hot, then the effect of that bias transistor on there that's on the heatsink should bring it all down. And we can actually show it happening. Let's let it stabilize for a while and see where we stop. Just get a different view here. That is still stabilizing. We're now at just under 11 millivolts. Now what I want to show you is I've got the soldering iron heated up, and I want to test the that protection, that bias compensation transistor there. Let's get rid of this. Now the reason that transistor is there is that if the heatsink, as the heatsink heats up, then so does the transistor, and what it should do is drop the bias current. Now what I'm going to do is I'm going to touch the soldering iron, not to the heatsink but to the actual screw that's holding it down, give it a bit of heat, and there we go, it starts coming down. If I take it away, it should start going up again, and it sure does. So the biasing transistor there, or bias compensation, works quite well. And it looks like this thing is actually ready for a proper test with some audio. Let's try that. I'm going to start with a very low level input signal. It's at 10 millivolts RMS, and activate the output. And what we've got there is 450 millivolts RMS output. So we've got audio now. Now I'm going to slowly ramp that up. 10 millivolts RMS input, 40, 50, 60, 70, 80, 90. There's 100 millivolts RMS, and that is 4 volts RMS, 4.1. And the output offset, the DC offset of the output, is slap on 0. So that's good. That is very good. Still very low power, obviously. I've got, what is it, I squared, V squared over R, so 16 over R is 2 watts. It's only 2 watts over there. I'm going to give it double that, 200 millivolts. We're still good. We've still got 0 offset. The light bulbs are starting to glow a little bit more because the current drawn is now 300 milliamps from the supply. Let me give it another light bulb. Everything still looks good. And give it another 100 millivolts. That's, whoa, 300 millivolts. The reason I went well was the light bulbs really glowed there. I'm not going to put it on full bypass just yet. So I've got 300 millivolts input coming in, 11.6 going out into the 8 ohm load. DC offset at the output is absolutely 0, which is good. Let me show you what's happening to the meters. Now the meter is showing, that's the DC offset, 1 millivolt. It was at 0, it's fluctuating between 1 and minus 1 millivolts. The bias current is no longer bias current because that's actually the effect of current flowing through there because of the signal, and I've still got 300 millivolts going in. I've still got 11.6 millivolts or volts RMS coming out at the resistor, the load, and I'm going to switch off the input now. What we see is this thing came down, and the reason is because of the actual signal going through there and the heat sink warming up a little bit. I mean, I'm touching it, it's just gone a bit above ambient, but because of that change in temperature of the heat sink, the transistor that's also heating and controlling the bias made that come down. And now as the heat sink cools, that'll go up a little bit as well to arrive at the true quiescent bias current. So this looks good. This looks good. I'm truly happy. I'm truly happy. Just thinking if there's anything else that I should be looking at right now. But no, I think that's it. Yep, this thing is the same as the other one, working the same as the other module, which is exactly what I wanted. Okay, so in summary, for now, what do we have on the modules? Well, we have, this is the first module I tried, this is the one I've just tested. This particular one is going to get 4 new transistors. There is that 39 ohm resistor which has to be swapped out. I'm going to replace that one and that one, and just for good measure I'll probably do those two as well. There's one resistor here, 5.6 ohms, which is reading a little bit high, so I'll probably replace that one, that one, that one, and that one. And this module gets 4 new transistors as well. Once I've powered them up again with the full complement, I'll have to be careful about the bias current because this one was never tested with 4 transistors. So I'll get the components in, do the replacements, and then we'll have these modules ready to do a final test. That is on the modules, but obviously that's not all. There's something else to do. This thing still has some work that needs doing. Cleaning up of contacts and so on, but more especially doing a thorough check of the protection relay board and just making sure that everything else is kosher, power supply, and then of course we still have a quick look at the 2 meters at the front. I'm not sure if they're all fine, but they'll have to be looked at as well. So what I'm going to do now is I'm going to leave you for a while. I'll get the components in and then publish a final video with the final checkups and tests, and then do an audio test as well. Well folks, thanks for watching. I hope you've enjoyed that. I certainly have, especially when it works out. And I'll be back soon. If you like this, please share, subscribe, and if you want to support the channel, please do so on Patreon. Bye for now.